In this video, we will learn how to find the determinant of a 3 by 3 matrix. A notable thing is, determinants can only be found for a square matrix. If the matrix does not have equal number of rows and columns, then you cannot find the determinant of that matrix. Let's proceed. Let's consider the 3 by 3 matrix, and I'm going to call it as A11, A12, A13, and so on. So to find the determinant, you need to first take any one row, and I'm going to take this first row, A11, A12, and A13. And I'm going to take this first element here and find the cofactor of this. All right. How do you find the cofactor of Aij? So to get the cofactor of any element in a matrix, you multiply it with -1 to the power of I plus j, I and j here, multiplied with the determinant of its minor. All right. So let's take this example and I will explain to you how to do this. Now, cofactor of A11 will be equal to -1 to the power ij is 1 and 1. So I have put it here as 1 and 1. Kindly note, this is very important that you take care while you're writing this power, that you make sure that it is in the exact row and the column. Because when you're writing the cofactor of an element, you will not be seeing this 1, 1. But you'll be seeing a value here on the matrix and you will be putting it. So just remember, this is the row and this is the column. So first row, first column, add them together. Multiply by the determinant of the minor. So what is a minor? To find a minor, here we are finding the minor of A11. Eliminate the elements which are in the same row and in the same column. So you're left with this A21, A23, A32, and A33. So let's bring that down here. Great. So you have here -1 to the power 1 plus 1 multiplied by the determinant of A23, A22, A23, A32, and A33. Next step, what we're going to do is, we're going to multiply this A11 with the cofactor of A11. So, this is A11, right, which is our A11. I'm multiplying it with the cofactor, which is this. This is nothing but the solution of the matrix, the minor matrix here. All right. So let's repeat the same process for the second element in the row, A12. So I've taken here A12 and we're going to find the cofactor. So to find the cofactor, you put -1 to the power 1 plus 2. 1 plus 2, why? Because first row, second column, right? Determinant of the minor matrix, which is M12. So follow the same principle to find the minor. To find the minor of M or A12, eliminate all the elements which are in the same row and in the same column. So you'll get your M12 as equal to A21, A23, A31, A33. Great. So let me bring it down here. So this is our cofactor. So we're going to repeat the same process as we did for the first one. So I'm going to add it with the product of A12 okay, multiplied by the cofactor of A12, which is this. I hope it's clear, right? All right. So we're going to repeat the same process for the last element in the row, which is A13. So A13, first finding the cofactor, you have -1 to the power 1 plus 3 multiplied by determinant of the minor M13. So M13 determinant will be equal to, eliminating the same item, the items in the same row and the same column. So you are left with A21, A22, A31, and A32. Let me bring it down here. So we have this. So repeating the same process, A13 multiplied by the cofactor of A13. So this, when you find the value of this, that will be the determinant of this matrix. All right, so let's take an example and let's try and do it. Let's consider the matrix A. Now, matrix A is a 3 by 3 matrix. Okay, so let's find the determinant of this matrix. So to find the determinant, let's bring this matrix down here. Replace the two brackets, open and close brackets, with straight lines. Okay. To find the determinant, you need to take any of the rows. So I'm going to take the first row here and I'm going to illustrate this for you. All right, so just go carefully with me. I will go slowly, and if you watch this video, then you will be able to do the determinants of any 3 by 3 matrix. I'm going to take it as easy and as possible for you. Now, let's take the first row. Okay, so you have element 3, 1, and 2 in the first row. I'm going to bring them all to the side. So I have 3, 1, and the 2. Okay, I'm going to multiply this 3 with the -1 to the power 1 plus 1. Why do I say 1 plus 1? Because 3 is in the first row, first column. So it's like first row, first column. Then let's take the number 2, which is here. Sorry, number 1, which is here. So the number 1 is multiplied by -1 to the power 1 plus 2. Why 1 plus 2? First row, second column. So first row, second column. Let's look at the last number, 2. Is multiplied by -1 to the power 1 plus 3. Why 1 plus 3? First row, third column, right? First row, third column. All right. So now this number 3 multiplied by -1 to the power 1 plus 1 will have to be multiplied by the determinant of the minor of 3. So what is the minor of 3? To find the minor of 3, eliminate the items in the same row and in the same column. So you're left with the matrix 4, 3, 3, and 4. So let's bring this over here. So next, let's repeat the process for the next one. So repeating for 1, which is in the first row, second column, we need to find now the minor. Right, so minor of 1, you need to eliminate the items in the same row and in the same column. So now you're left with 5, 1 and 3 and 4. So that's our minor determinant. Watch this. So to get to the minor of 1, you remove the items from the same row and the same column. Then the remaining will form a submatrix. So this is the minor matrix. So determinant of this is what we need. So let's bring it over here. Next, we have to find the minor of 2. So to find the minor of 2, eliminate the items in the same row and in the same column. So now you have this matrix 5, 4, 1 and 3. So let's bring that over here, right? So let's create some space. So it's saying, now we're going to simplify. So by simplifying, what I'm doing is, you have the same 3 here, minus 1 to the power 1 plus 1, which is 2, multiplied by, this is the matrix, determinant of this matrix. So 4 times 4 minus 3 times 3. So you have it here, 4 times 4 minus 3 times 3, which is the determinant of this 2 by 2 matrix, plus 1 times minus 1 to the power 3 multiplied by the determinant of this matrix, which is 5 times 4 minus 1 times 3, okay, plus 2 multiplied by minus 1 to the power 1 plus 3 to the power 1 plus 3 multiplied by the determinant of minor 2, which is 5, 4, 1, 3. So to find the determinant, multiply 5 times 3 minus 1 times 4. Alright, if we start to simplify this, we will get this, and then further simplifying and simplifying and simplifying, the value of this determinant is 26. So please note, determinants can only be found for a square matrix, which means the matrix should have equal number of rows and equal number of columns. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.